Hi, welcome to Video Math Lessons. Tonight we're going to do Math 12, Pre-Calculus, and our topic is polynomials. The lesson for tonight is going to be Descartes' rule of sign. So Rene Descartes was a mathematician and philosopher. If you ever heard the quote, I think therefore I am, then you've heard of Rene Descartes. But we're concerned more about his mathematical skills. So Descartes' rule of sign, pretty much this is basically what it says. If you have a polynomial, in this case we have a third degree polynomial, by looking at the sign changes in the polynomial, it would tell us about the roots. So for example, let's take a look at this polynomial here. This polynomial is third degree, and the way it's drawn here, there's one negative root and two positive roots. And by shifting this around, I could have three positive roots, or if it was the whole thing on this side, there'd be three negative roots. There could be, if it was up in the air, like this, one positive root, and since there's only one positive, that means there's going to be two imaginary roots also. Or conversely, if I was a negative root, I could have two imaginary roots also. But the total roots for this problem, since it's a third degree, it'll be three. So Rene Descartes' rule of sign tells us how to figure this out without a graphing calculator. All right, so let's begin. So it goes this way. So Descartes' rule of sign is a method to determine the maximum number of positive and negative real roots. Of a polynomial. All right, now this is how it does it. So what we're going to do is we're going to count the sign changes. Count sign changes. So if we have f of positive x, which is the original, this would be for the positive roots. And if we do the other one, f of negative x, this would be for the negative roots. And that's Descartes' rule of signs. So let's look at a couple examples. And you'll see this is actually really one of the it's really an easy topic. So here we go. First question. Number 1. F of x equals x cubed plus x squared minus x plus 1. All right, so Descartes' rule of sign says this. So first we just look at the original. That's the positive. And I look at the sign changes. I don't care about the coefficients. I don't care about the power, really. As long as they're in descending order of powers. And if there's some missing, you just ignore them. So this starts with a cube, it goes squared, standard form, that's what we call it. And I'm just looking. So this x cubed, to start with, is positive, negative, and a positive 1. And now what we're going to do is count the sign changes. So wherever it turns from positive to negative or negative to positive. So here it changes. That's one change. Two changes. So since this was the original, this was f of x, there's two changes. So it's two roots. Or, remember that picture we had earlier? If the graph was hanging up in the air, they could be imaginary roots. Now you have to remember, imaginaries always occur in conjugate pairs. So I would subtract 2 off because you do not have one imaginary root. There would always be 2, a plus minus. So you subtract off imaginaries. So I'm subtracting off conjugate pairs. That's why I subtracted by 2. Now, I don't know if there's 2 roots or there could be no positive roots. I don't know, but I just didn't know. I could have a maximum of 2, or there could be 0, because I would count down by 2s. If this number happened to be like a 4, I would subtract 2 down. So it'd be 4, 2, 0. If this number was a 3, I still subtract 2, right? So it'd be 3, subtract 2. So it'd be 3 or 1. Let's do the negative. So now we do negative. All right, so now I'll do it the long way the first time. Then after this, it actually kind of goes. I'm going to substitute, wherever I see x, I substitute the negative. Now, what does this do? Well, let's think about this. If you have an odd power, it stays whatever it was. So this turns out to be negative x cubed. Even powers always become positive, excuse me. So a negative x squared will turn positive. So this would be plus x squared. And I'm using the signs here also, so I'm just working the problem down. Now look at this one. Negative negative is positive x. And this is plus 1. The constant on the end will not change its sign. So now when I look at this, I'm looking at it this way. Negative, positive, positive, positive. So we count the sign changes. 1, and it stays the same. So this would have 1 negative root. So this was 2 or 0 positive roots, 1 negative. Now, what does this mean, the 1 negative? I don't subtract conjugate pairs because they don't have enough. So I know flat out this would have 1 root. And I could graph it, 1 negative root, excuse me. I could graph it and check it, but I don't have to. Because all I'm asking is what's the max number? So if they ask me what do I have, I got 2 or 0 positive roots, or 1 negative root. Or I should say and 1 negative root. Let's try it again. Question 2. This one I actually graphed. We don't need to graph it. So let's look at the positives. So I'm just going to run through it. So it's positive, positive, positive. It's all positives. There is no sign change. So I know there's 0 positive roots. You can even say it doesn't. There's no way it's going to hit the positives. So let's do the negatives. Now, when I cube a negative, it becomes negative. So it would be negative. Even powers stay positive. It will turn positive. This becomes negative, and this one becomes positive. So count the sign changes. 1, 2, 3. So it could be 3. But what if, now if you look at it, there's 1 negative. So that means 2 are imaginary. So I'm going to subtract off the conjugates. So it's 3 or 1, which is this case, there's 1. So this is our answer. 0 positives, 3 or 1 negative roots. Try it again. So I'll do the positive one first. And I don't care. This doesn't have an x squared. It doesn't matter. Just skip it. So positive, positive, negative. 1 change. There is 1 positive root. And actually, I graphed this one. You can see there's 1 positive root. Do the negatives. Negative cubed is negative. Positive times negative is negative. And this one is negative. There is no sign change. There are no sign changes. So therefore, it is 0. do one more. So once you set it up, make your pluses and minuses. And write down your answer. Positive, positive, negative, negative. I got one change, therefore it's 1. Substitute. Negative to the 4th would be a positive number. Negative squared is positive. Negative times negative, positive. Constant will stay. One and one. And you could graph this if you really wish, but it doesn't mean. Now, what are we going to use this for? Well, what's going to happen is this. What we would do is our polynomials, when we do the rational root there and we list out all the possible roots, well, when we don't have a calculator, what we're going to do is we can knock out. If I know there's no positive roots, then I won't check positive numbers when I do it if we were not using a calculator. Or if I knew there was no negatives, I only check the positive numbers. So that's what we're going to use it for. That's about it. So if you have any questions, you can always check out. There's a good website. It's called purplemath.com. And that's about it. So have a nice night. Thanks.